Hello, Algebra 1 students. You have made it to your first asynchronous class. We are starting with Unit 2, Lesson 2 of the I Am Algebra 1 curriculum. The link is on Canvas, and you should also have it bookmarked in your taskbar. We're going to start with, just to point out two things, the title, Writing Equations to Model Relationships, Part 1. And then the learning goal for this lesson is let's look at how equations can help us describe relationships and constraints. So that's kind of the goal of the lesson and what you should get out of it. So starting with 2.1, 2.1 is a math talk. We'll do these periodically throughout the year. When we do them live, you'll have a chance for quiet think time to think of different strategies to solve each of the problems, and we'll have a chance to share and compare strategies and see how they relate. For now, because we're doing it as an asynchronous lesson, go ahead and take a couple minutes to think through mentally how you would solve each of the problems, and then write your answers. I'm going to pause, and then when you come back, I'll have you check your work. Okay, welcome back. So for 2.1, you might have approached the first three in different ways, but you should have ended up with 50, 24, and 16. And in looking at how those values are related to the original percentage, they're all double. So then for P, which is just a placeholder for any number or any percentage of 200, that same relationship will hold true. So the result should be 2P. Great. All right, we're going to move on to 2.2. Here is 2.2. To start with, there are three figures shown, a tetrahedron, a cube, and a dodecahedron. Take a minute, pause again, just to write down at least two similarities between the three figures and two differences. Okay, welcome back again. So some of the similarities you may have seen in the figures are that they are all made up of a single polygon. The polygons themselves look like they're regular, meaning the side lengths are all the same. There are an even number of faces and edges and vertices. Some of the differences are that they are made up of different polygons. If you noticed other similarities or differences, make sure you make note of that to share it later. Let's move on. So for this next part, you're going to fill in the table for the number of vertices, edges, and faces for the cube. The tetrahedron and dodecahedron have already been done for you. And then you're going to look at the relationship of the faces, vertices, and edges within each shape and see if you can come up with a relationship that generalizes how a Platonic solid works. I'm going to pause again and give you a chance to work on it, and then we'll come back and talk about it. Welcome back. Okay, so for 2.2, you're asked to first complete the table for the number of each, the faces, the vertices, and the edges for the cube, 6, 8, and 12, and then to make some observations. It only asks for 2, but you may have found more. For example, all of the numbers in the table are even. The number of edges within a set of 3 is the greatest number. You may have also noticed that the number of edges is 2 less than the sum of the faces and vertices, and that relationship holds true for all 3 shapes. So 4 plus 4 is 8, minus 2 is 6, 6 plus 8 is 14, minus 2 is 12. 12 plus 20 is 32, minus 2 is 32. So it seems to be a consistent relationship. And then for number 2, it asks you to explore a relationship between those three values, face, vertices, and edges. And so I expressed it as the number of faces, F, plus the number of vertices, V, minus 2 equals E, the number of edges. You may have written this relationship differently, but check to see that it's equivalent, because that's really the important part, is that we've captured that relationship. All right, we're going to move on to the next section. You'll notice, if you're on the online version, that there is a drop down for Are You Ready for More? Are You Ready for More is just an extension, and they're usually built into every lesson. They're there for you to do if you're up for it and you have the time. For now, though, we're going to skip over it and move on to 2.3. I'm going to ask you to pause again, take a minute to read through the problem, record your answers, and then come back and check your work. Welcome back. Okay, so for 2.3, first you're asked to just write equations for each situation. You may have gotten a variation of something that I got. For example, for E, I said V plus 45 equals M. You may have gotten M minus 45 equals V. Those two are equivalent, so they express the same relationship. So take a second first to check your answers and see if you have any questions. And then the next question asks you to look at what are some of the similarities and what are some of the differences between the two sets of equations. So there are the blueberry equations and there are the Noah and my equations. So looking at similarities first, one thing I noticed is that in the first equation for both, there's only one unknown. In the second equation, there are two unknowns. And in the third equation for both, there are three variables or three unknowns. So that's one way they're like. Each of the three equations within each also have three variables or terms. Variables or numbers, which are terms or quantities in the equation. So the values themselves might be different, but they all are made up of three different values. Some of the differences, the values themselves that are being used. For example, 4.99 is different from 45, so the values are different. And also, the relationship between cost and blueberries is multiplicative because I'm multiplying the unknown. And then in the second set, it's additive. I'm adding a quantity to an unknown or two unknowns. One other kind of generalization to take away from all the equations in both of the sets is that you will run into situations where there's just one unknown value. You could have a situation where there are two unknown quantities, and then also situations where there are three or more unknown values. And it depends on the information given in the problem itself and how those relationships relate. Great. We're going to move on now to the last section of this lesson, which is 4.2. Go ahead and pause your video again, read through the problem, answer the questions, and then come back and check your work. Welcome back again. Okay, let's go over 2.4 together. So you're told that there's a tax on a car in Michigan of 6%. This dealership in Ann Arbor also includes another $120 in miscellaneous charges. and that there are different parts of the relationship for the total cost of the car. P, I noted as the price. The sales tax is 6%. The miscellaneous charges, if I didn't know them, I might note them as M. But in this case, we know that they're equal to $120, and the total price of the car. Before I started answering the specific questions, I thought about how all of those different values relate. So I could say the price of the car plus the 6% tax. And remember, when you're calculating in percent, you have to convert either to a decimal or fraction equivalent. You can't actually calculate 6% in percentage. So 0.06p would give me plus the 6%, plus the miscellaneous fees will give me the total of the car altogether. You may have noticed that for the cost of the car plus the tax, that both of those are p's. And so they're the same variable and implied same exponent, which is 1. So they're considered like terms, so I could combine them and write the same expression as 1.06p plus equals t. Great. All right, now let's answer the questions below. So the original car price is $9,500. So I'm going to fill in what I know. So I can do 1.06 times 9,500 plus 120 equals T. The original car price is $14,699. $14,699. So again, I know the tax and I know the price. So combined, it's going to be 1.06 of the total price plus the miscellaneous fees. When the car costs $22,480, again, it's just going to be 1.6 of the cost plus the miscellaneous fees equals T. And then I'm going to generalize that relationship. So instead of a specific price, for any price P for a car, it's going to be 1.06 P, 1.06 times P plus 120 equals the total price of the car. Take a second to check over your work and make sure you understand how each of the equations came to be. Then for the second question, it asks, how would each equation you wrote change if the tax on the car sale is R% and the miscellaneous charges are M dollars? So in that case, instead of knowing specifically that the miscellaneous charges, M, are 120, they're unknown, right? So we're going to leave them as a variable M. So in all of the cases, but in the generalized one, it would mean that our equation would change from 1.06p plus M for the unknown miscellaneous charges equals the tax. And if we didn't know the sales tax, whatever that sales tax is, its decimal equivalent would be 100% the total price plus the decimal equivalent. So I could say P plus RP plus M equals T. One thing to note here, though, is that the R, remember I said earlier that you can't calculate with a percentage, you have to actually convert it into something. And so the R would need to be divided by 100 in order to make it something I can calculate with, so that it's a decimal, not just a percent symbol. So if I didn't know the percentage or the miscellaneous fees, my equation, I'll write it again a little clearer, would be P plus R over 100 times P plus the miscellaneous charges equals the total. Again, pause here, see if you have any questions, check your work before moving on. Okay, the final part of this lesson, and every lesson will have this, is a summary. The summary is nice because it takes all of the ideas that were covered in the lesson and pulls them together. If you are to miss a lesson, this is a great place to start in terms of reviewing what you may have missed. For every lesson, you should read through the summary, highlight any key terms that come up, and also check off skills that you're able to do. So, for example, when it says, letters are helpful for representing quantities that vary. If F represents the number of students who are going, T represents the number of teachers, and C represents the total cost, we can model the quantities and constraints by writing. And so can you, without looking at the equation that's given, could you come up with your own equation? And if not, if you're not sure where each of these values came from, then go back through the lesson, check in with me, make sure you take down notes so that you can clarify any misunderstandings you have before moving on. And that is it. Congratulations, you did your first virtual lesson. For prep and practice, you're going to complete the practice problems, which are also linked on Canvas. See you later.